Hello everyone. Today we are going to continue solving radical equations, but we're going to see that we're adding in something that is a little tricky today. We have a couple problems to start with before we get into the actual problems for this section. The first thing that we are going to do is actually just check answers. It's really important for these solving radical equations problems that you're checking your answers when you're done, because sometimes we're going to do all the right math steps, get some numbers, and then some of them aren't going to work. So it's your responsibility to make sure that they do. So we're down here at this first one right there. We're going to plug in the solutions and see if they work. So we're told that 4 and -7 are what we got, and we're going to plug that in everywhere we see an x. So starting with 4, we're asking ourselves, is that equal to the square root of 28 minus 3 times 4? 3 times 4 is 12. 28 minus 12 is 16. And we're still asking ourselves, are these two things equal? Square root of 16 is 4. So it works. So 4 is a solution. And we have checked that. Looking over at -7, very similar thing right here. Is -7 equal to the square root of 28 minus 3 times -7? Now being careful with your signs, 3 times -7 is -21, but subtracting -21 is like adding. So we have -7, is that equal to the square root of 28 plus 21, which is 49. And we get is -7 equal to 7. Now, the square root is already in the problem. It's already there. We're just taking the square root of 49, which is 7. 7 and -7 are not equal to each other. So -7 is not a solution. Remember, if a square root is kind of already there, the sign is just what's on the paper. If you are to introduce a square root into a problem that wasn't there before, that's when we get two different answers. Taking a look at the next one, I'm going to do this one a lot quicker just to check. So we're going to start with -4. The square root of 12 minus -4, is that equal to -4? This is the square root of 16. Square root of 16 is 4. It's not equal to -4, so -4 is not a solution. Checking 3, square root of 12 minus 3, is that equal to 3? Because we're plugging in 3 for this n right there. Square root of 9, is that equal to 3? And it is. 3 is equal to 3. So 3 is a solution. It is now your turn. Pause, try out the next one, because something you might have looked at as well, looks like the negatives never work. So I'm guessing that -3 down the next problem doesn't work. That is for you to try. Come back in a second when you're done, and I'll have my answer ready to go. All right, so taking a look at my work, and hopefully it matches yours, we see that 3, didn't even write it down right. -3 is a solution. 2 is not. So don't just assume because it's negative that it won't work. Please just check your answers, see if it works. The other thing we have to be prepared for today is we have to remember how to solve by factoring or quadratic formula. I'm going to do each one once and ask you to try the other one, and then as we move on, you're going to do whichever one makes sense to you, whichever one you're more comfortable with, even though I will recommend factoring if things are factorable. So I'm going to grab a different color and let's look at the first example. If you remember, for factoring and quadratic formula, to solve those equations, they need to equal 0 first. One side needs to be 0. So looking at example 1, I'm going to subtract 2x and 15 to the other side. And we get x squared minus 2x minus 15 equals 0. That's what I mean when I say it has to be equal to 0. Now at this point, you're thinking factoring quadratic formula. I'm going to do both. Factoring is what I'm going to start with. So if you remember factoring, we do the a coefficient times our c, which is 1 times negative 15, which is negative 15. We take our b coefficient, which is negative 2, and we ask ourselves, we need two numbers that multiply to negative 15, add to negative 2. And if you give yourself a moment, that is negative 5 and 3. Now, hopefully you remember factoring. I'm going to do it the long way. We're going to take that middle term, negative 2x, and break it up with these two numbers. So x squared minus 5x plus 3x minus 15 equals 0. And then we're going to do some grouping and GCF factoring. So we look at the first two. We can take out an x. We're left with x minus 5. We look at the next two. We can take out a 3, leaving us with x minus 5. And since those x minus 5 pieces match, we can factor those out. And what are we left with when we factor both those out? We're left with x plus 3. X plus 3 equals 0. And then here is the other thing. You can't forget, this is not done. We haven't solved. We're trying to find the value of x. So to solve when we're in factored form and it's equal to 0, you take each of the factors and set them equal to 0. A little bit more algebra, you see that our answers are 5 and negative 3. Now, I'm going to run through quadratic formula really quick and then ask you to try the other one. I'll write down the answers, but it's going to be on you to write those down and try those out. If you didn't want to factor and wanted to use quadratic formula, x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. And then it's just cleaning it up from here. Opposite of negative 2 is 2. Plus or minus the square root of negative 2 squared is 4. Here's where you got to be careful. Watch your signs. There's a minus here and a negative there. When you subtract a negative, it's the same thing as adding. 4 times 1 times 15 is 60. Over 2 times 1, which is 2. And then going just a little bit quicker here, 64 is under the radical. Hopefully you know the square root of 64 is 8. And then we get our two answers by doing 2 plus 8, which is 10, divided by 2, which is 5, and 2 minus 8, which is negative 6 over 2, which is negative 3. You see that we get both the same answers. Now, at this point, I strongly suggest pausing, doing example 2 yourself. I'll give you a second to do that. And we'll tell you that the answers are 6 and negative 5. If you need some help with that and can't figure it out, send us a quick message, join some office hours, but try that on your own. Now we're getting to the good stuff. So yesterday you learned how to deal with radical equations, but you will hopefully notice today we have variables on both sides. So we got our steps labeled out here for you. Please follow them, go step at a time, and we'll get through this. All right, isolate the square root on one side, meaning if there's stuff not under the square root, you move it to the other side. For our problems that we're doing, things are generally going to be isolated already, but that's not always the case. Not always. If you look at our problem, the square root stuff over here on the right-hand side, it's already by itself. So we're done with that. To undo the radical, as you saw yesterday, we're going to square both sides. So I'm going to square this, and I'm going to square this. Writing what we get x squared equals, squaring a square root undoes it. We have x squared equals x plus 12. Now, this should look like those two problems that you and I did above. This is a quadratic. And how do we solve quadratics? Factoring or quadratic formula. You're going to see me do factoring for the rest of this. If you want to do quadratic formula, be my guest. It should work. First thing we need to do, make sure that one side is equal to 0. I'm going to subtract x and 12 from both sides. We get x squared minus x minus 12 equals 0. If we're going to factor, a times c is negative 12, b is negative 1. Sorry, that's looking a little sloppy there. Two numbers that multiply to negative 12 add to negative 1, negative 4 and 3. In this one, I'm going to take the shortcut. Since our a value is 1, you might recall that we can kind of skip that factoring by grouping stuff and go straight to our factored form. And we take our factors, ooh, that didn't look good, set them equal to 0. We get x equals 4 and negative 3. And here is where a lot of people tend to make mistakes. You got to go back and check our answers just like we did at the beginning. So we're going to take 4 and negative 3 and plug it back into the top equation, the original starting equation. So is 4 equal to the square root of 4 plus 12? Yes, it is, because 4 plus 12 is 16. Square root of 16 is 4. Is negative 3 equal to the square root of negative 3 plus 12? No, it is not. Negative 3 plus 12 is 9. The square root of 9 is 3. 3 is not equal to negative 3. Therefore, x equals 4 is our final answer. X equals negative 3 is extraneous. Something that made sense when we did our work, however, doesn't work for this problem. At this point, I am going to do one more. And, well, actually, just kidding. You're going to do the next example for me, please and thank you. And then I'm going to show you how to do number 3, so then you can try the last one on your own. So please take a pause, do the second example, then we'll go through the third example together. All right, welcome back. Looking through example 2, the radical is isolated, so we square both sides. We move everything over to one side. I got x squared minus 2x minus 3 equals 0. Through factoring, I saw that my two solutions are 3 and negative 1. Checked them. Negative 1 didn't work. It's an extraneous solution, so x equals 3 is the final answer for that one. All right, example 3. This one's just slightly different. Same process, slightly more challenging. The radical is isolated, so we're ready to square both sides. Here is where you got to be careful. Hopefully you've noticed I've been writing parentheses around those square roots. I think it's helpful to think that way because when we look over on the left-hand side, you have to square that side. It's not just writing a square up there because that's going to get you a mistake. Put parentheses around it. We're squaring that whole thing. What is 2a squared? Well, it's 2a times 2a, which is 4a squared. I'm just pointing this out because if you're going to make a mistake on these problems, it tends to be, algebraically tends to be there. If you're going to mess up along the way, that's an easy place to make a mistake. It's not 2a squared. It is 4a squared because you do 2a times 2a. Or if you remember our exponent rules, it's 2 squared times a squared. Squaring a square root gives us negative 8 plus 5. And then we got a quadratic again. So I'm going to move everything to one side. I'm going to add 8a and subtract 5 to the other side. And you might notice that we now have a problem where the leading coefficient isn't 1. These were our harder ways to factor things, so I'm going to go through that just a little bit. We take our A coefficient, multiply it by C, which is negative 20. Our B coefficient is 8. Two numbers that multiply to negative 20 add to 8. Oops, sorry about that. Ooh, going all over the place. That happens to be 10 and negative 2. But you got to remember, we got to go through that a whole ordeal with factoring this way. So I'm going to write it out long ways. 4a squared plus 10a minus 2a minus 5 equals 0. We use 10 and negative 2 to break up that middle term. Looking at the first group, the GCF is 2a, which leaves us with 2a plus 5. Here's where another mistake happens looking back to factoring. When we factor this, oops, don't want that a there. When we factor this, we want 2a plus 5 left over. These things need to match. We do not currently have 2a plus 5. We have negative 2a minus 5, so we got to factor out the GCF of negative 1. And at this point, we're going to factor this to 2a plus 5 times 2a minus 1 equals 0. We set each factor equal to 0. Something that if you don't write down, sometimes we tend to forget how to solve these. We subtract 5 divided by 2. A equals negative 5 over 2, or maybe you're going to write down negative 2.5. Or we add 1 and divide by 2, and we get 1/2, or maybe you'll write down positive 0.5. Now before I say we're done, oops, that was not what I wanted to do. Before I say we are done, remember we got to check our answers. Now this is a little bit harder to do by hand. 2 times negative 5 halves, is that equal to the square root of negative 8 times negative 5 halves plus 5? Well, 2 times negative 5 halves is negative 5. 8 times negative 2.5 is 20 plus 5, so that's the square root of 25. Negative 5 is not equal to 5. Square root of 25 is 5. So, negative 5 halves, negative 2.5, that is extraneous. Oh, I'm sorry, I'm kind of writing all over the place. Testing out the other one, 2 times 1/2, is that equal to, where is it, negative 8 times 1/2 plus 5? Well, 2 times 1/2 is 1. Negative 8 times 1/2 is negative 4 plus 5. It's the square root of 1. So 1 is equal to 1. So A equals negative 1/2 is our solution right there, while negative 5 over 2, or negative 2.5, is extraneous. All right, this video is going long. You try out the last one. I'm going to write down all the work, and then we'll wrap it up. So you pause, try it out. We'll be right back. All right, ladies and gentlemen, take a look at what I did. I'm hoping it matches yours. Radical is by itself. Squared both sides. Moved everything to one side. Oh, I guess I should say, please make sure you had 4y squared. Move everything to one side. I factored, having to do our factoring by grouping stuff. I got answers of 2 and negative 3/4. If you check those, you will see that negative 3/4 is extraneous, and y equals 2 is our solution. So on Thursday, you're going to be practicing what you did yesterday and today, and this stuff is not easy. If you are stuck on some things, if you want some help with anything, please reach out for assistance, or you can wait for Thursday to try the problems out to see if you understand them. I hope you have a great rest of your day. I'm hoping this made sense, and I hope you are all doing well. See you next time.